I don't know where everybody else is, but they can catch me on YouTube. Speaking about YouTube, I don't know if you've noticed my 1211 YouTube channel. I'm a star. And last night after I posted, I thought, let me look at it more than just a few snippets. And I saw on that YouTube some wild and crazy guy, me, having a lot of fun, and I do. By the way, I just did a generation gap on you. For those of you who remember the Saturday Night Live from the mid-70s, 1970s, I was a grad student then. They had a couple of skits with Steve Martin, and I forgot who else were there. Two wild and crazy guys. But anyways, looks like the YouTubes are being looked at, and hopefully they're working for you. All right, as promised, I'm going to be doing my world famous review for the next test, which is tomorrow. If you go to the assignment area right now, you'll see that you can download now, if you want, the PDF file that's test number 1 is password protected. Tomorrow morning, I'll email out the password and you type it in, open it up, and take the test. Now, because this is technically asynchronous course, you'll have until Friday, 9 a.m. to upload the single PDF file, and it's in the instructions, which I also have in the assignment area, and I also have the green periodic table. Please don't cheat. You shouldn't be looking at your notes. You shouldn't be talking to other people in the class or getting other help from other people, and you shouldn't be going on the internet looking for answers. I have put, and I learned how to do this last semester, certain traps in there that I can catch people cheating. Hopefully you don't, but if you do, I will do what's in my syllabus. But for the most part, I know you're all reputable people. You know something, I'll retract that statement. I think you all are reputable people, but it's good to remind students of that. All right, let's get going. What you're going to see, I posted yesterday in Blackboard in the lecture file. Can everybody see when I get test number 1 review on the screen? Can you guys see? Thank you. Thumbs up, people. All right, let's go through this. What you're seeing now is in Blackboard for you to download. All right, first of all, I started out talking about chemistry. You should know at least one of the 4 branches of chemistry. They're organic, inorganic, physical, analytical. I'm quite biased. Organic's the best because I'm an organic chemist. Next, I talked about the chemical symbols. And chemical symbols we've been using, and on my slides for lectures, couple of chapters, there are only, I think, 37 elements. I've asked you to learn the symbol and the name for those elements. All right, after that, we started talking about the metric system. And the metric system is a way of measuring different things, and the prefix in front tells you something about the unit. And when you have a kilo, that's 10 to the 3rd times the unit. So if you have a kilogram, that's the same as 10 to the 3rd grams or 1,000 grams. Milli, and this is stuff you should know, is 10 to the minus 3. So if you have a milligram, that's 10 to the minus 3 gram or 1,000th. And same thing with a milliliter is 1,000th of a liter. Now, centi is 100th. And therefore, if you have a centimeter, that's 100th of a meter. And finally, nano, because it's important, you'll see in the coming years will be more important, is 1 billionth. A nanometer is 1 billionth of a meter. And back in 1995, chemists found how to make these little tubes, very little, and they call them nanotubes because they're a billionth of a meter, very tiny. And they're playing more and more important role in our life. Now, next thing I taught you was scientific notation. And I'm going to switch to my pad here. Time for the thumbs up, people. Can you see a blank piece with the pens on top? Good. Thank you, thumbs up, people. All right, for scientific notation, it's a number that's, let's call it Z times, why the hell are you doing this? Hold on one sec. There. I don't know why I was doing that. It wanted to burp on me, and it did. All right, scientific notation is Z times 10 to the n. Z here is never less than 1, greater than 9.99 times. It's less than, never less than 1, and never 10 or greater. N is a number. Now, when your number is greater than 10, N is positive. One of the things I saw in the video, you can't see it, but my little arrow, now you can see my cursor, but from my pen where I can see an arrow, you don't. Now, when the number is less than 1, N is negative. Oh, by the way, tonight at midnight on Zoom, I'll be giving lessons how to read my handwriting. Not really. And if it's between 1 and 10, N is 0, because 10 to the 0 is 1. But I've never put that on a test, so I won't. But you should know this. So if I have a number and how do you write that in scientific notation? You look where, if there were a decimal, it would be right here. There's not. You move it to the right of the first integer. I moved it 1, 2, 3, 4. So this is 1.26. When there's no decimal at the end, you drop the zeros. When it's greater than 1, I see a question. Thank you. But anyways, let me get back. And now, make the decimal a little nicer. How many times do we move it? 4 times. Now, I'm going to let you do one more. We did these already. Now here, notice the number is less than 0. You still move the decimal point to the right of the first integer. 1, 2, 1, 2, 3 times, 3.7. Now, when there's a zeros after the decimal point, you're doing scientific notation, you keep that. And I moved it 1, 2, 3. Because it's less than 1, this will be a negative number, and it's 3. And that's how you do scientific notation. And I also went through how to go from this number back to that one. Now, the next thing I talked about was significant figures. And significant figures is a way of showing the accuracy of a measurement or number. And there are various rules for significant figures. First one is all non-zero numbers are significant. Go look at my notes, slides for this chapter too. It's in there. I'm not going to rewrite them now. And zeros at the beginning of a number are never significant. Zeros at the end of a number without a decimal are not significant. Zeros at the end with a decimal are significant, and zeros confined between two non-zero numbers are significant. And just to give you an example, you know something, I'm going to share the fun. All right, why don't you have some fun and tell me how many significant figures, do it on your own, then I'll go through the answer, are in A, B, and C. I should share the fun. And I do. One of these days I'll record and play back game show music while you're doing your thinking. Nah. Anybody need more time? Going once, going twice. Nobody's yelling. Let's do it. All right. All non-zero numbers are significant. Zeros at the end without a decimal point are not. So this would have three significant figures. There's a decimal point here. It was tiny. Hope you saw it. All non-zero numbers are significant. Zeros after the decimal point are significant. So this would be 1, 2, 3, 4. You ignore this part for significant figures. So this would have 4 significant figures. Next one, zeros, and there's a decimal point here. Zeros in the front, lead zeros, are not. Next, non-zero numbers are. Zeros confined between two numbers are. And zeros at the end, where there's a decimal point, are. So this would be 1, 2, 3, 4, 5. And that would be 5 significant figures. Now, when you do a calculation, and especially on your calculator spreadsheet, you may get a number like this. And the question is, how do you know what number you should get? Now, the first thing, let's go back to here. I don't have on here, but there are rules for multiplication division to determine significant figures of answers. For multiplication division, you get the same number of significant figures in your final answer that the number that you multiplied or the numbers that you multiplied or divided that had the fewest significant figures. So if you multiply, say, 3 significant figures times 7, your answer significant figures, your answer should have 3 because that's the lowest number. Now, your calculator or spreadsheet is going to spit out a lot more. And then you have to round it off. And let's look at this one. By the way, I use the abbreviation sig fig and handwriting now. So you keep the first significant figure, you keep the second one, you keep the third one. The one to round off, if this number is 4 or less and you're past the decimal, you drop this, and the answer would be 5.46. If you had a number like this, and you had to round it off to 3 significant figures, this one's a little challenging. I'll do it. Keep this one, keep this one, keep this one. This is the round off. This is 5 or higher. You'll drop this, increase this by 1. This becomes 0.10. So the answer here, and hold on. Oh, somebody beat me to it. I was wondering maybe you couldn't see it, would be 7.90. And that's how you round off. Now, if the number is greater than 10, the number you round off and everything you used to round off and either drop or replace with a 0, and everything else you replace with zeros. So if we have, which you usually don't deal with this, but you still should know how to do this. How do you round this off to 3 significant figures? Keep this one, keep this one, keep this one. This is the number you round off. It's 5 or greater. You're going to increase this by 1, but since it's greater than 10, this, and if there was a number here you'd replace by 0, the number would be 125,000 or 12,500. And that's how you round off. And that's an important thing. The key thing to remember is that when you're rounding off, how do you know what to round off? When you multiply or divide, you get the same number of significant figures as the number that has the fewest significant figures. For addition, you have the same number of significant figures past the decimal as the number that has the fewest significant figures past the decimal. I'm going to give you one to try out. What would be the answer? On test number 1, and as now, it will say, please use proper significant figures for all calculated answers. If you don't, I take off a point for an answer. I'll give you 3.6 seconds. 1, 2, 3, 3.2, 3.4, 3.55. Time's up, 3.6. And if you look here, what do we have? We have 2 significant figures. How many do we have here? 4 significant figures. Which should be the answer? How many significant figures? Hang on while I check the chat, see if there's a question. You guys are ahead of me. I'm feeling proud of you. You should have 2 significant figures because that's the lowest number. This would be 6. How do you write 6 in two significant figures? Like this, 1 and a 0 past the decimals, significant. And throughout the whole semester, you should know how to do that. Now, a couple of times I talked about the chemical symbols. And you should know the chemical symbol and names for the, I think it was 37 elements I asked you to learn. Next, we went into chapter 3. Chapter 3 talked about matter, and I thought about it. You should know, what is matter? It's something that has mass and occupies space.
Hi, Professor.
Yep.
Can we do an example of addition and subtraction, please?
Of course.
Okay, thank you.
Let's do addition. I don't think I've ever put a subtraction on test number 1. Oops, I gave something away. Anyways, if we add it up normally on your calculator, you get something like this. And notice this has 1, 2 significant figures past the decimal. This has 1 past the decimal. So you now look at this and say this is 1 past the decimal. This is a number to round off. It's 4 or less. I'll drop it. And therefore, the correct answer for this addition using significant figures would be that. Now, let me give you one. Let's change this to 6. And why don't you try that? Add 3.336 to 4.11. I see people already flashing their answer, so I better get to work. All right, let's do this one. This would be 7.446 if you did it on your calculator. Now, your addition, how many significant figures past the decimal point? 1, 2, 3. All numbers, including 0, are significant past the decimal. So this has 3 significant figures. This has 1, 2. So now you have to round this off to 2 significant figures, because when you add or subtract, you get the same number of significant figures past the decimal point that the number that has the fewest significant figures that you add or subtract. So we keep 1, we keep 2. This is what we use to round off. Is that, since we're past the decimal, first of all, is that 4 or less, 5 or higher? 5 or higher. So we're going to drop this and increase this by 1. And the correct answer for this, using significant figures, would be 7.45. Remember, since high school, I thought this is the coolest way to write a 7, which is the German or European way. Okay. And remember, in my class, all questions are good questions. Now, back to chapter 3. We talked about matter. Something very important you should know are the 3 states of matter. And that is solid, liquid, gas. A solid, and I didn't write it down because I was lazy last night. Yeah, Dr. White gets lazy, but I went through this and it's in the slides and should be in your notes. Know the definition. A solid has definite shape and definite volume. A solid has definite shape and definite volume. A liquid has indefinite volume, but definite, I got it wrong. That reboot, a liquid has definite volume, but indefinite shape. A liquid has indefinite shape, but definite volume. And finally, a gas has both indefinite shape and indefinite volume. And you should know that. Next, I talked about an important concept in chemistry, and that's properties of chemicals and elements. And there's two types, physical and chemical. And you should know examples for each. I won't ask you the definition, but a physical property is something you can measure that shows something about the property of the substance you're looking at. Just like if we said, ooh, look at sulfur, it's yellow. And bromine is a red gas. Those are physical properties. Now, chemical property is water doesn't burn, but gasoline will. That's its propensity to undergo chemical reactions. Now, the next thing I talked about was physical and chemical changes. And that happens in a case of a physical change, that's when it changes its state of matter. An example of a physical change is when water freezes. It goes from liquid to solid. Or an ice cube melting. That's a physical change. Goes from solid to liquid. You could also say water boiling goes from liquid to gas. Now, a chemical change is when you see something change into something else. An example of that would be if there's metal that rusts. Another example of that is a chemical change occurs in your stomach, not to scare you, but it does when you digest food. The food is undergoing a chemical change. And never try this at home. Well, you can this one. When you see the flame on a candle, the wax in the candle is undergoing a chemical change we call combustion. Now, next I talked about the different different temperature scales, Fahrenheit, centigrade, Celsius, I always use the wrong old name, and Kelvin. And you should know how to convert from Fahrenheit to from Celsius to Fahrenheit, from Fahrenheit to Celsius. And finally, Kelvin, hold on. Kelvin is degrees C plus 273. Now, it's very important to understand that 1.8 and 32 in the first two formulas are exact numbers, and exact numbers never affect the number of significant figures your answer should have. Also 273 in the last formula. If you look in the lecture folder of Blackboard at the bottom, I have important information, test number 1, and the only for this test I'm giving you are these 3 formulas, so you don't have to memorize them. Thank you, Dr. White. You're welcome. But anyways, you should know how to go from Fahrenheit to Celsius, from Celsius to Fahrenheit, and Celsius to Kelvin. Now, one of the stupidest things I've ever seen on a test, which I will never, going from Fahrenheit to Kelvin. I've never done that, but teachers who want to trick students do that. I don't. And as I mentioned before, this and other things, if you can do the practice problems for these chapters 1 through 4, you're in good shape for test number 1. Next, finally, we got some good chemistry. Hold on. I haven't done it all morning. I have to do it. Time out for fun from Dr. White. We got to talk about real chemistry. Don't you like the way my eyes do this? See, chemistry's fun. And chemistry, when you talk about chemistry, the smallest particle of an element that has all the properties of an element is the atom. And the atom, you should know, is made up of 3 subatomic particles. First one is electron, and it has a negative charge. Proton, positive charge. Neutron, no charge. Again, you should know that the atom is made up of 3 subatomic particles: the electron, negative charge; proton, positive charge; neutron, no charge. For anyone who showed up a little late, what I'm showing you now, test number 1 review, is this file. So you can see these pages whenever you want. It's in the lecture part of Blackboard for my class. Now, I briefly talked about, and you should know, Thomson's cathode ray tube experiments, and that showed mainly that you should know the electron has a negative charge. Also, I talked about Rutherford's gold foil experiments, and Rutherford's gold foil experiments showed that the nucleus of the atom is very dense, small and heavy. That's what it means by dense, and that's why the particles that he shot at the gold foil bounce back sometimes. You should also know that the nucleus, which is the center of an atom, contains the protons and neutrons, and since a proton is positive and neutron has no charge, the nucleus has a positive charge, and all around it are the electrons. Next, I showed you the periodic table, and I taught you that the atomic number equals the number of protons and also equals the number of electrons. And you should know the atomic number equals the number of protons and number of electrons. Everybody see the periodic table now? Thank you, thumbs up, people. All right, this is the periodic table you'll be able to download from the assignment area and use for test number 1. You'll use it for 2, 3, 4, 5 in the final. And if we look at an element, say hydrogen, in the upper right-hand corner, you see the number 1, that's the atomic number, and that tells you hydrogen has 1 electron, 1 proton. If we go over to my favorite one, carbon, I'm an organic chemist, and organic chemists love carbon atoms. And notice the atomic number is 6, and the atomic number tells you number of protons and electrons. Therefore, carbon has 6 protons, 6 electrons. Why don't you figure out how many electrons and protons chlorine has? Time's up. First of all, chlorine chemical symbol is Cl, and the atomic number is 17, and that tells us chlorine has 17 electrons and 17 protons. Now, next, I talked about the periodic table, and the key thing you should know that the periodic table has groups, which you know as columns, also known as families, and there are 4 families or groups you should know: the alkali metal, alkaline earth metals, halogens, and noble gases, which Dr. White still uses at time. like you saw the other day, the old name, inert gas, but I checked when I did test number 1, I got it right. If I have it in there, it's going to be noble gas. And let's go to my favorite periodic table. And if you look here, the alkali metals are lithium, sodium, potassium. There are others, but I only asked you to learn these 3. And you should know, if I ask on a test, give an example of an alkali metal, you could put, and this chemical symbol, you could put down K for potassium, Na for sodium, or Li for lithium. Hydrogen is not an alkali metal, even though it's in the same column. That's the one exception to the whole periodic table. Now, you could have put rubidium, cesium, or francium, which I've never used. I have used lithium, sodium, potassium, but that's that. Next one, the alkali metals, alkaline earth metals. The 2 I asked you to learn would be magnesium, Mg, calcium, Ca. Then if we go over to the other side, which unfortunately this periodic table doesn't have a little nice color, but the second to last column are the halogens: fluorine, chlorine, bromine, and iodine. I've never worked with this one or this one. Well, anyways, I don't even know how to pronounce them properly, astatine, but I've worked with iodine, bromine, chlorine, and fluorine. And if I ask on a test, give an example of a halogen, oh, you could put down Br bromine. If I ask, give the name and a symbol of a halogen. And finally, the last one, the noble gases are the column all the way on the right. And if I ask on a test, give an example of a noble gas, well, you can put down Kr krypton. Remember, in our universe, krypton is a colorless gas and will not kill Superman. You can put down argon, neon, and helium also. All right, I was looking at keeping an eye on the chat in case. And the final thing, which I thought about, and I talked about briefly, but you should know that a metal has properties of luster. That means you can shine it up. Thermal conductivity, it conducts heat. That's why your pots and pans are metal. And it has electrical conductivity. That's why the wires in your house are copper made of metal. And it has malleability, which means you can thin it, pound on it, and make it real thin. And that's how you get gold leaf foil and aluminum foil I use, I don't know if you do, in my kitchen. The end. Any questions about test number 1 material? Like I said, the best way to study for test number 1 is to do the practice problems. Also, come to think of it, you can look at my great Zoom meeting videos and also the videos I have from Chem 1105 that pertain to our course. Next day or two, I'll be generating a list of videos from, from 1105 that you should be watching for the material I'm covering now for test 2. Suela.
Yes, Dr. Wood, I have a question. So in this one, there is not going to be ions and cations?
Oh, what?
They're not going to include onions? Ions.
Nope, nothing on ions.
Nothing on ions?
Okay. That will be on test 2.
Okay.
I put it down as it's in your book, and I have, when I skip things that spend a lot of time. If you bought the book and the book, students get upset. And the last thing I want are upset and frustrated students. So that's why I put it in my notes. But if I haven't given you practice problems on ions or talked about it in depth, it's not going to be on the test. And this is the way I teach. One thing I should say, generally in a review, I cover all the main topics, but the last time I checked, I don't walk on water unless it's frozen. Even then I stay off it. So once in a while I will forget something, but I think for this review, I didn't. At least I hope I didn't. All right, let's move on. Go back to chapter 10. We're talking about ions. And let me back up. And positive ions, when you have ionic bonds, you transfer electrons from one atom or group of atoms to another atom or group of atoms. And when an element loses one or more electrons, an ion with a positive charges form. We call that a cation. And yesterday I started teaching you how to determine what ions a element can form. And the way to do it is an element will want to gain or lose electrons to have the same number of electrons as the nearest noble gas. And hopefully, let me check with my thumbs up people. Everybody see chapter 10 slides? Thank you, thumbs up people. I'm gonna have to get t-shirts made up. Dr. White's thumbs up people, nah, but you can make your own. All right, now, we did magnesium. Let's go back and do another one. Ah, I can't spell this morning. All right, so the question would be, draw the ion formed from sodium. Well, first thing you have to know is the chemical symbol for sodium is Na. Next, that's not what I want, hold on. Can you see the periodic table now? Let me check everybody, can you see the periodic table? All right, and I'll know I do this and this is why I have my thumbs up people. Thank you, thumbs up people. Wednesdays, I'll get this down straight by the end of the summer. But anyways, sodium, Na, atomic number is 11. To figure out the ion, you have to know, first of all, sodium has 11 protons, 11 electrons. What's the nearest noble gas numerically based on atomic number? 18 is argon, that's 7 away. Neon is 10, 1 away. So it will want to get, I see a question. I see someone got the answer right already. Neon will want to go to 10 electrons. Let me check now. Thumbs up, people. Can you see sodium on there? Thank you. Now, you don't have to write this on a test, but here's the mindset. Sodium, how you do it. Sodium has 11 electrons, 11 protons. It wants to go to be stable to an ion that has the same number of electrons as neon, 10. It will still have 11 protons. And now if we look at this, we know each electron is a -1. Each proton is a +1. Do the math, -10 plus 11. These are exact numbers, so you don't have to worry about significant figures, because I don't know how to get half an electron. Show me and we'll be rich beyond my wildest dreams. That goes beyond having my own Lamborghini and Ferrari and fleet of jets to play with. All right, add this up and you get a +1. Now notice it said up here, draw the ion. How do you draw an ion? You do the chemical symbol, then superscript right. If it's plus, you put plus the number. The number is 1, you just put the plus sign. If I do it good. And that's how you do it. That's all what I circled you have to put down. But what I have up here is the mindset, knowing you start with these many electrons and protons. Sodium wants to have the same number of electrons as nearest noble gas, neon, nearest being closest numerically by atomic number. Protons never change. You do the math, and then you add it up, and that tells you. And why don't you try this one? What ion, oh, that looks awful. Hold on. That looks better. Now Dr. White's happier, which is a good thing. What ion does calcium form? And hopefully you should all see the periodic table now. I'll let you try. Go. By the way, in case you haven't learned, hopefully you did for tomorrow, calcium is here, Ca. Remember, what I'm going through now is on test 2, not test 1, which is tomorrow. All right, time's up. Put down your pencils and pens. Let's take a look. How do you do this? Here's calcium, atomic number 20, which tells you it has 20 electrons, 20 protons. Which is the nearest noble gas numerically? Krypton at 36, 16 away. Argon at 18, 2 away. And hopefully you all picked argon. So calcium wants to go to having 18 electrons. Again, what I'm writing, you don't have to do on a test, but I'm showing you the mindset, how to do this. This wants to go to 18 electrons, the same number as, which I just talked about, I just forgot. Mental block to argon. And it will not lose the number of protons. Do the math. Every electron is a -1. Every proton is a +1. This equals -18 plus 20. Add it up, you get a +2. And calcium forms a +2. You can write it this way, or I like this way myself, but it's perfectly correct on the test to write it this way. Now, this is called a calcium cation, Ca+2. I'm going to go another couple minutes, and then we'll take our break from 5 till 10 o'clock because I'm worried. Let me check. All right. Now, how many of you have heard that calcium helps form strong bones? Calcium. Yes, Dr. White works out with weights. But anyways, in fact, later today, I'll be doing my workout. I do it every other day. And calcium. That means if you take calcium, you'll have strong bones. And the answer is yes and no. Now, calcium, the element, is a metal, like my ring, hard. Do you want to eat a metal? No, you'll break your teeth. What they really mean when they say calcium is good for strong bones is take calcium cations and you consume molecules that they put in milk or anything, or like I do, calcium supplements. The best is calcium citrate, my personal opinion. And I take 2 a day. Yes, I'm a little older and I don't want to have osteoporosis, which I don't. But anyways, you're not eating calcium, the element. You are eating calcium ions +2 ions, because that's the only ion it forms. So next time you look at something and says it's fortified with calcium, they're talking about ions. And remember the first day I said, my world of chemistry is your world of chemistry, and it's everywhere around you. By the way, I stole that from SpongeBob. But anyways, it's all around you, and it is. You know something? This is a good time to take a break. I'll give you an extra 30 seconds more. Come back at 10 o'clock. That's when the big hand is on to 12, or for those with digital watches, 10:00. And I'll see you. I'm going to go do my stretching exercises. So I've been sitting for a while. So have you. All right, let me get you back, call everybody back. It's time to begin again. All right, we're talking about ions. Well, I didn't take the English part. No, I'm just kidding. But anyways, time to do more ions. And we talked about positive ions. When an element gains electrons, you form a negative ion. And let's take a look. Same thing, what ion will the following form? I'll do this one. You know I'm going to share the fun. And first of all, you have to know chlorine has a chemical symbol Cl. Now, we go to our periodic table, and hopefully everybody can see the periodic table. Time for my thumbs up, people. Yep, thank you, thumbs up, people. I'm going to have a special club insignia made up. But anyways, we look at chlorine. Chlorine is right here. What's the nearest noble gas? Argon, 1 away. Neon is more than 7 away. Krypton is a lot more than 1 away. So the nearest noble gas is argon. Now, chlorine has 17 electrons and 17 protons. Argon has 18 electrons. Remember, atomic number tells you the number of protons and electrons. So what that means is chlorine wants to get to 18 electrons. The number of protons never changes. Remember, each electron has a -1 charge. Each proton has a +1 charge. Do the math. Do the math correctly. Add it up and you get a -1. And how do you show that? Well, when there's a -1 or +1, you show the chemical symbol, and then superscript, you put the charge, since you don't have to put the number 1 there. If it was other than 1, you put the minus sign and then the number this way, or you put the number first and then the minus sign. And I'm going to share the fun. What ion does oxygen form? And let's get a periodic table up for you. In case you haven't learned, hopefully you have, oxygen chemical symbol is O. Again, the question is, draw the ion that oxygen will form. I'll give you another 22.76 seconds. Bonus time, 5 more seconds. Time's up. Now, here's oxygen. How many electrons and protons does it have? Look at the atomic number, 8. So oxygen has 8 electrons, 8 protons. It wants to have the same number of electrons as the nearest noble gas. And that is neon, because that's 2 away, helium is 6 away, argon is 10 away, which is the closest numerically by atomic number noble gas. So oxygen wants to have 10 electrons. Remember, the atomic number tells you how many electrons and protons. It still wants to keep the same protons, but it wants to get 2 more electrons because that will make it very happy. From the atomic number, we know oxygen has 8 electrons, 8 protons. It wants to go to the same number of electrons as neon, which is 10 electrons. But the protons stay the same. Well, I'm getting better at this writing tablet. Boy, I should mess up now. But anyways, each electron is a -1 charge. Each proton, see, I'm even getting quick at erasing my mistakes, is a +1 charge. By the way, mistake I made, I do that on a whiteboard at COD too. But anyways, do the math. -10 plus 8, add it up, -2. How do you show that ion? Chemical symbol, superscript right. It's a -2, or the newer way, which I like the older way, 2-. Either one would be correct. And that's how you determine ions. Now, once you determine it, that's the one that's always going to be for the chemical elements I'm dealing with. Some metals can be more than 1 ion. We will not cover that in this class. And as you just saw, we covered negative ions. When an element gains 1 or more electrons, it has an ion with a negative charge. And by the way, that's called anion. And as I showed you here, chlorine forms a chloride anion. That's what it's called. Speaking of that, how many of you are familiar with the term anode and cathode, like in batteries? And that comes from the ions that are formed in the battery. And in the anode, there's negative. At the cathode, from cation, there's positive. Bet you didn't realize the batteries you use in your daily life, there are chemical reactions going on. We'll talk a little about that way at the end of the semester. Now, before I start this, time out for a commercial from Dr. White. Don't forget, from 6 to 7 on my evening Zoom ULR, I will have my office hour. And if I need to stay a little later to help someone out, I will. Shh, don't tell anybody I'm being nice. It'll ruin my image around COD. But if you need help tonight, I'll be available. Come to the Zoom channel and I'll be there. Now, we're talking about molecules. One type of molecule is called an ionic compound. And ionic compound, as I talked before, is a compound which has ionic bonds, and ionic bonds are formed by transfer 1 or more electrons from one atom or another to another atom or group of atoms. And because atoms want to get the most stable form, ions, they can give up electrons or accept electrons. And when such an electron transfer occurs, you get positive and negative ions, and they attract, forming an ionic compound. So you have a positive ion, negative ion, they attract. I think you've all heard in life, opposites attract. All you have to do is look at my best friend Neil and his wife. Neil and I have been friends, I hate to say this, since about 1965. Wow. And when he got married, I have been pleasantly pleased. He got married in '78. I'm as close to his wife too, which I'm quite lucky, because I know a lot of people who have best friends and they're not close to the spouse of that best friend. But anyways, they are totally opposite, and they've been happily married now for many decades. But in chemistry, same thing, ions, positive, negative, they attract. That's called the Coulombic force, Coulombic from electrical, coulombs. And that attraction forms a chemical bond we call an ionic bond. I like the expensive props I'm using. I don't stop at any expense. I'll go to every expense to help my students out. So let's look at one. Ionic compounds, like I said, positive, negative ions are held together by strong electrical attraction between opposite charge. We call that an ionic bond. Now, important thing, when we form an ionic compound, we have what's known as charge balance. And that indicates that the number of ions and their charge that make up the ionic compound, the sum of those charges is always zero. All molecules in nature have a net zero charge. All molecules in nature have a net zero charge. And let me stop here and go into something. I thought I had a slide, but through the miracle of my writing tablet, let's look at one we just did. You just learned that sodium forms a +1 cation by losing an electron, and chlorine forms a -1 anion. Now, where does this get this electron? It got it from the sodium. Now, notice this is a positive cation, negative anion. They'll be attracted together and they'll form an ionic chemical bond, which we can write the chemical. Oh, that looks awful. That's better. Let me make this disappear. And this is sodium chloride. And you notice table salt. By the way, I might have mentioned, if you ever go out with me or other chemists to lunch, breakfast, or dinner, one of us, and I've done this too many times not to own up to it, will say, please pass the NaCl. NaCl. Yes, you can smile now. But anyways, why does sodium chloride only have one sodium and one chlorine? Because notice the sodium has a +1 charge, the chlorine has a -1 charge. Add those together and you get a net charge of 0. And that is why sodium chloride isn't Na2Cl5 or anything like that. It's one chlorine and one sodium. So next time you're at a party, a Zoom party, I got to change my jokes considering social distancing. Hopefully one of these days that will be over with, but for now, be careful. But if you're on a Zoom party and you see someone putting salt on their French fries, you can say, you know, that's an ionic compound that has a sodium cation and a chloride anion held together in an ionic bond. Don't. You lose a friend pretty quick, or they'll go click and you won't be in the Zoom party anymore. People don't like hearing chemistry during parties. Trust me. All right, let's look at what this also means. Come on. I got to practice my writing on a tablet. All right. By the way, in actual classroom, students will ask me, what's that on the board? And I have to decipher it when I wasn't writing. The question would be 3 points each. Write the chemical formula for the compound for the compound formed from or of the following ions. And A is K plus Br minus. And let me show you how to do that. This is a +1. This is a -1. All molecules have a net zero charge. So if I have one of each of these, it will be 0, net zero. So the formula would be KBr. Let me do one more, and then I'm going to let you have some fun. And the question would be, what would be the formula for a molecule made up of calcium +2 ions and chloride -1? This is a +2. This is a -1. It should add up to 0. It doesn't. When I'm stopping like this, all right, somebody beat me to it. Now, you cannot change the charge. Students like to do that, and it'll always be wrong on a test. But you can change how many of them. If I have 1 chlorine, that's a +2, how do I get a -2? Because that will add up to 0. You put a 2 in front of there. +2, -2, 2 times -1 is -2. So how do we show that? 1 calcium and 2 chlorines. Remember, subscript to the right shows you that. By the way, this molecule, I think I already mentioned it, are the little white pellets you use in the winter to throw on your sidewalk to melt the ice when it's super cold. Why don't you try this one yourself? I'm going to share the fun. Write the chemical formula for the compound formed from magnesium +2 and fluoride F -1 ions. All right, time's up. What do we do? Well, we get a little more room here. We know this is a +2 cation. This is a -1 anion. It has to add up to 0 because all molecules have a net 0 charge. If you find one that doesn't, let me know, because then I can be rich beyond my wildest dreams. That goes beyond my own island in the South Pacific. My dreams with money can get pretty wild. How do we get this to add up to 0? We can't change the charge, but you can change how many. This is a +2. I want this to be a -2. Now 2 times -1 is -2. And now that will be a 0. So what this tells us is you have 1 magnesium and 2 fluorine. That would be the molecule. Now, I talked about before polyatomic ions. And I'll do this one. What would be the ion form? Now, notice this is a +2. This is a -1. It has to add to 0. It doesn't. I can't change the charge, but I can change how many. And I'd need 2 of these, +2, 2 times -1, -2. Now it adds up to 0. How do I write this? Well, there's 1 calcium, but now I have 2 of this polyatomic ion. When you have a polyatomic ion, you put the ion inside a bracket when you have more than 1, and then to the right in subscript, you put how many? In this case, 2. And that's how you would do it. I don't know, where was I on E? Why don't you try this? What's the chemical formula for a molecule with magnesium +2 and hydroxide? That's what this is called. I'll never ask that on a test. -1. Go. And thank you for all those who are putting the answer in chat. You're getting them right too. All right, let's do this. This is a +2 ion, cation, and this is a -1 hydroxide. Here, let me check real quick. Thumbs up, people. Can you see the screen? Thank you. All right, now this has to add to 0 because all molecules have a net 0 charge. This is a +2. This has to be a -2. We can't change the charge, but we can change how many. And therefore, if I have this and this, how do I write this? This is 1 magnesium because the number in front of the +2 is 1. And now I want 2 of the hydroxide. It's a polyatomic ion. When a polyatomic ion, Let's try that again. When a polyatomic ion, there's more than one, in this case two, you put it in a bracket, and then how many you have, if it's more than one, that's when you put it in a bracket, and then we need two of them. Oh, let's do one more, because these are fun. What would be the formula, the molecule formed with sodium +1 cation and sulfate -2 anion? Go. I'll give you 8.6 seconds more. 3, 5, I've got a slow clock today. 7, 8.2, whatever I said. All right, let's take a look at this. This is a sodium +1. How do you know that? From right here. This is a sulfate -2 anion. It has to add to 0 because all molecules have a net 0 charge. It doesn't. How do I get this to 0? This is a -2. This has to be a +2. I'll put a 2 in front. Don't change the charges. Students try to do that. It's always wrong. So what does this tell me? The molecule has 2 sodium and 1 sulfate. When it's only 1, you don't put it in brackets. That's sodium sulfate, which I talked about previously. That's the material they put in those little packets that they tell you do not eat. And that keeps it dry, whatever it is. One of the things lately I've been addicted to, I got to stop eating them because they're so good. I like them. My best friend hates them. And that's the little strips of roasted seaweed snacks. Yeah, I like them. Dr. White has a wide range of food I like. There's only two things, couple things I won't eat. My mother liked chocolate covered ants. No insects, and no sheep's eyes. I've seen it served in a restaurant. But anyways, listen carefully. Don't forget, tomorrow in the morning, I'll send out an email with the password so you can open up the PDF file and take the test. It's in the assignment area. Also, I have instructions so you know how to make a PDF file if you don't have a scanner and upload it to the assignment area. You'll have till Friday morning. If you do not do a single PDF file, I reserve the right to take off up to 25 points from a test score if you don't. Last semester, I took off 5 points because it was a lot of extra work for me to have to make if you upload individual JPEG files, a lot of work, and I don't need that. So don't forget to do that. Tomorrow we have our normal Zoom lecture, and we'll talk about the lab on Zoom, which just try it tomorrow. Don't worry about it. I'll talk more tomorrow. And with that, I get to use this again. Goodbye. I'll see you either tonight in my office hours or tomorrow morning in our Zoom meeting. Have a great day. Guy and Gesund, or Gay and Gesund. Hold on. Gay and Gesund. Be healthy. I'll see you tomorrow. Bye.